This is the introduction to section 7.3, part 1. In 7.3, we're going to start to work with proving triangles similar. So now we're going to go back to using some ideas and proofs. And there's two things here. We're going to use the angle-angle similarity postulate and the side-angle-side similarity and side-side-side similarity theorems. That's what you're going to see a lot of today. We're also going to use similarity to find indirect measurements. Okay. So, you can show that two triangles are similar when you know the relationships between only two or three pairs of corresponding parts. Okay. Now, these are not the same as proving them congruent. Remember, congruent is different from similarity. So, the first postulate we're going to look at here is the angle-angle similarity postulate. What it says, if two angles of one triangle are congruent to two angles of another, then the triangles are similar. So, if two of the corresponding angles are congruent to each other, then the two triangles are similar to each other as well. So what they've said here is angle S is congruent to angle M. Those two are in the same position. Angle R is congruent to angle L. Those two are in the same position. Therefore, if you have two angles that are in the same position congruent to each other, the two triangles are similar to each other. Okay, so what they're going to have you do now is they're going to have you see, are the two triangles similar? And if so, how do you know? So what I want you to do is hit pause and see if you can figure these out before we go through them. Okay, now that you're hit pause and you've went through these, it says, are the two triangles similar? And if so, how do you know? Well, again, the only way we know how to prove right now is by using the angle-angle postulate. So I've got to prove that two corresponding angles are congruent to each other. Well, as you look at the first, we know that angle R and angle V, those two guys are congruent. So we're one down. You also know that these two angles are congruent because of vertical angles. So, yes, these are similar by the angle-angle similarity. Okay, so I could say triangle RSW is similar to triangle VSB. Okay, so again, all you have to do is show that two of the angles are congruent. Now, as you look at letter B, we've got one 70-degree angle, so we're good there. These two angles are 70-degree, angle R and angle L. And then we've got 85 up top, and we've got a 30 on the bottom. Now let's take the left triangle first, and let's fill in the other angles. We know if one's 70 and one's 30, that's 100. That means this angle right here is 80. And if I have 70 and 85, that's 155, which means this bottom angle down here is 25. Now, as you look at the angles, do I have any other pairs of angles that are congruent to each other? No, I don't. So these two are not similar. We don't have enough information there to show that they are similar. Okay, now let's take a look at the other two similarities theorems that we're going to look at. The side-angle-side similarity and the side-side-side similarity. They're fairly straightforward. Okay, so they're essentially what they say they are. So it says if an angle of one triangle is congruent to an angle of another, and the sides that include the two angles are proportional, then the triangles are similar. So, you'll notice you see where the angle is here. Angle A and angle Q are congruent. Okay. And the sides that include them. So these two sides have to be proportional to these two sides. So AB over QR is to be equal to AC over QS. And you have to check that when you're going through to prove that those are similar to each other. Okay. If that is the case, if they're proportional and one of the angles in between that is congruent, then we can say that they're similar. Okay. The second one is the side-side-side similarity. Now, in this one, on the side-side-side similarity, it says if the corresponding sides of two triangles are proportional, then the triangles are similar. So if I take all the sides that are corresponding, so AB and QR, and AC and QS, and BC and RS, and I set them up into a proportion, just like we did with a statement of proportionality before. If all those come out to the same fraction, and when you reduce them for the scale factor, then you know that the triangles are similar. Okay, let's go through a couple of examples here now. Are the triangles similar? If so, write a similarity statement for the two triangles. Okay, so first of all, do we have any angles as you're looking at that? Do we have any angles marked in here? Well, no, you'll notice we don't have any angles marked at all. So I'm going to try and show the side similarity. So I need to match up my proportional sides. So I've got ST over XV has to be equal to SU over, if I go SU, I have to go XW, and that's going to have to be equal to UT over WV. Now, if I set these up, these should all be the same numbers. So ST is 6, XV is 9, equals SU is 10, XW is 15, and UT is 8, and WV is 12. And now I need to reduce these. So these first two will reduce to 2/3 if I divide them by 3. If I divide these guys by 5, that's 2/3. And if I divide these guys by 4, that's 2/3. So all of these are the same. Since all of those are the same, I can now say that triangle SUT is similar to triangle XUV, or XV, let's see here, XWV, and they're similar by the side similarity. Okay. All right, so let's take a look at letter B now. On letter B. So now on this one, you'll notice that these two shapes share the same angle. So I know that angle K is congruent to angle K. So I want to try and use side angle side if I can. So I got to show that the two sides included are proportional. So as you look at the two triangles here, you've got the small triangle right here, KLP, and then you got the big triangle, KMN. All right, so I'm going to go small over large. So I'm going to go KL over KM has to be equal to KP over KN. Now they only give you two sides, and that's okay. They don't have to give you all of them. So KL in this case, KL is 8. KM is, if you look at KM, figure out how far KM is. KM happens to be 10. And that's going to equal KP, which is 12, over KN, which is 15. I have to add those two segments together. Okay, now what I have to do is I have to check to see if these are going to reduce to be the same. So I divide these guys both by 2, that's 4/5. If I divide these guys both by 3, that's 4/5. So these two are exactly the same. And I also have an angle that's the same. So I can say now triangle LKP is similar to triangle MKN by the side angle side similarity. Okay, so I've given you 3 examples there, talked about 3 new similarities, how to prove 2 triangles or 2 shapes to be similar. Okay, this concludes section 7.3 part 1. Make sure you complete your WSQ.